Welcome students in the organic chemistry lecture series. In this video we are going to start the nomenclature system for stereoisomers. Generally stereoisomers are named by four different system of nomenclature. The first system of nomenclature is DL nomenclature. The second system of nomenclature is Erythro and threo nomenclature. Erythro and threo nomenclature. The third system of nomenclature is Z system, and the fourth and most important system is RS nomenclature. In this video we are going to focus on the first three system of nomenclature, that is DL nomenclature, Erythro threo nomenclature and ZE nomenclature. This system of nomenclature we have to study in detail, so it will be required two or three lectures for this RS nomenclature. So today in this video we are going to study about these three systems: DL nomenclature, Erythro threo nomenclature and ZE nomenclature. We'll see one by one. Okay, so first of all we'll see about this D and L nomenclature system. To correlate the structure and configuration, this DL system of nomenclature was induced by the scientist Fischer. This scientist introduced this system. Fischer assigned the configuration to optically active compound by choosing the example of glyceraldehyde. Okay, the dextrorotatory form of glyceraldehyde was assigned as a D configuration, and levorotatory glyceraldehyde was assigned as a L configuration. Okay, I will take one simple example so that you will understand. Suppose I have a general Fischer projection formula like this R, and suppose here is a H, and here is suppose X, and here is suppose R dash. Okay, so if this X is on right hand side, then this Fischer projection is called as D form. Okay, similarly if we draw the structure like this R dash, and suppose now here X is on this side, that means left hand side, then this system is called as L configuration. Okay, so if the X is on right hand side, then it is D, capital D, and if X is on left hand side, then it is L configuration. So I will take one example so that you will easily understand. Glyceraldehyde, if we draw the Fischer projection formula of glyceraldehyde, and it is represented as like this: CHO, here is a CH2, OH, here is a H, and OH group is on this side. So if this OH is on this right hand side, then it is called as D or bracket plus glyceraldehyde. So you remember this is very important. So if OH, that is hydroxy group, in the Fischer projection formula is on right hand side, then it is called as plus D glyceraldehyde. Similarly, if we draw like this, suppose CHU group is here, CH2OH group is here, and now if we write OH group on left hand side, then the name of this will be L glyceraldehyde. Okay, so this is very important, that if OH group is on right hand side, then it is plus D glyceraldehyde, and if this OH group is on left hand side, then it is L glyceraldehyde. Okay, again I will take the example of lactic acid. Okay, so lactic acid Fischer projection we can represent like this: COOH, CH3, OH and H. Okay, so if this OH is on right hand side, then it will be D lactic acid. Okay, and if we draw the structure like this: OH on this side, all other groups are on the same position, then the name of this will be L lactic acid. Okay, so all these examples were in which there is only one asymmetric carbon atom, but if there are more than one asymmetric carbon atoms. Say for example, if I will draw the structure of glucose, see this CH2OH. Here is a CHO, H, OH, OH, H, H, OH, H and OH. Now to determine D and L form of such kind of structure, where molecule contains more than one asymmetric carbon atoms, then the lowest asymmetric carbon atom is taken into consider. Now which is lowest asymmetric carbon atom? This is lowest asymmetric carbon atom. So we have to consider the position of X on this group. So see here, this OH is on right hand side. So the name of this compound will be D-glucose. D-glucose. If we draw the structure like this, CCHO, CH2OH. See, all other groups have same position, OHH, OH, H, OH, H, and if we draw OH on this side, there is a H. Now we have to consider the lowest asymmetric carbon atom. This is the lowest asymmetric carbon atom, and OH group is on left hand side. So the structure name of this compound will be L-glucose. So I think all of you have understand that how D and L nomenclature is assigned to the stereoisomers. Actually, capital letters D and L do not have any relation with the small d and small l. Remember, this is very important thing. Sometimes we get confused that capital D and small d are same, but it is not the case. Remember that capital D and capital L are the configurations. Okay, these are the configuration. And what is small d and small l? Small d and small l represent the direction of rotation. Just it is just a sign of rotation. Okay, so capital D and capital L are far different than small d and small l. They are not same. So I think this nomenclature system is clear to you. So we'll move further. Okay, now let's consider the another system of nomenclature, that is erythro and threo nomenclature system. To understand this system, you have to remember a very simple thing. If the two similar groups are there in the projection formula, and if they are on the same side, then that isomer is called as erythro form. Now you see this structure here, these two similar group, that is this OH and this OH are on the same side. So this form can be called as a uh, erythro form. Erythro. Okay. And if the two similar groups are on the opposite side, then this form is called as threo form. So it is very simple. If the two similar groups are on the same side of the projection formula, then it is called as erythro. And if the two similar groups are on the opposite side of the projection formula, then it is called as threo. Similarly, we can take the another example. If we take the tartaric acid, then we will draw its erythro and threo form. The projection formula for tartaric acid is like this, COH, COH. So if both the OH groups are on the same side, then it will be called as a erythrotartaric acid. Erythrotartaric acid. And if these OH groups are on the opposite side like this, suppose here is one OH, here is another OH, H, and both OH groups are on the same position, which where at they. Now this is called as threo tartaric acid. Tartaric acid. So you remember that if two similar groups are on same side, then that configuration is called as erythro. And if they are on opposite side, then they are called as threo. So I think this is very simple. Again, we can take another example of this threo and erythro. See this, I will draw one of the example. Suppose here is a CS3, here is a CS3, here is H, here is H, here is Br, here is the OH. Okay, now again we'll draw like this: Br, OH, H, H, CS3, CS3. Now you see here, you have to consider these two groups. Don't consider hydrogens for giving erythro and threo nomenclature. Just consider the bulky groups. Now see this Br and OH are on the same side. So the name of this compound will be erythro 3-bromo 2-butanol. This will be the name, and the name of this compound will be threo 3-bromo 2-butanol. So in this way we can give the threo and erythro nomenclature to the projection formula. So I think it is very simple and understandable. So we'll move to another system of nomenclature. Okay, now see this system of nomenclature, which is called as ZE nomenclature, or it is also called as cis and trans isomer. To understand this system of nomenclature, I have taken a very simple example. See this acid, here these COH groups are on the same side of this double bond, so it is called as malic acid. And if the COH groups are on the opposite side of this double bond, then it is called as fumaric acid. So this will be cis isomer, and cis is called as Z. You remember, this is a trans, or it is called as E isomer. So if the say groups are bulkier groups are on same side of the double bond, then it is called as Z isomer, that is cis. And if they are on the opposite side, then it is called as trans, or it is called as also E. So the isomer in which contains at least two similar groups on the same side, then it is called as cis isomer or Z isomer. And if they are on the opposite side, then it is called as trans isomer or E isomer. Okay, so we'll take one few more examples. Suppose this is the another example. Here is a hydrogen, here is a suppose chlorine, here is a suppose bromine, and here is a suppose CSA group. Now if the groups are not same, then we have to give the numbers as per atomic number. The group which is having more atomic number will give first number. Now see this carbon atom. On this carbon will have highest priority. So one number give to this carbon, this hydrogen have second number. Okay. Similarly, on this carbon, this bromine is having one number, chlorine is having two number. Now you see here, this is 1 1, this is 2 2. If this is the case, then it is called as Cis form or Z form, we can say. Or you take another example. Suppose this is like now bromine is here, and chlorine is here, CS3 is here, and hydrogen is here. Now the numbering. Now this carbon will get first number, as carbon has high atomic number. Hydrogen will get second number. Now on this carbon we have changed the position. Bromine is having high atomic number, so it is 1, and it will have 2. Now see this 1 and 1 are on opposite side, 2 and 2 are on opposite side. So this is called as trans, or it is E. Okay. So in this way, by giving numbering, we can determine the Z and E form. Okay. So I think in this lecture we have seen the three system of nomenclature. First system we have seen was D and L nomenclature. In second system we have seen it was threo and erythro nomenclature, erythro and threo. And third system of nomenclature we have seen it was Z and E nomenclature. Okay. In incoming videos we are going to study about this RS nomenclature system. It is very important. So I think these three system of nomenclature you have understood very easily. In incoming video we'll see about this RS nomenclature. So today we'll stop here, and we'll meet in the next video with this RS nomenclature of system. So have a nice day. Take care.